This video is for the 8th Knowledge Organiser for Year 8 Delta classes. It is the second Knowledge Organiser on parallel lines. What I'd like you to do is read the Knowledge Organiser, watch this video and work through the examples on page 1, try the questions from the Knowledge Organiser on page 2 and complete any Maths Watch work set. So this Knowledge Organiser is the second Knowledge Organiser on parallel lines. So today what we're going to do is we're going to find the equation of a line that is parallel and passes through a point. So to start off with, we look at this question here. It says find the equation of line L which passes through the point 5, 8 and is parallel to y equals 3x plus 2. The first thing you do is you have to identify the gradient. So the gradient of this line is going to be 3 because it is y equals 3x plus 2. So we've got the 3 there. We're then going to use the general formula for equation of a straight line, which is y equals mx plus c, and we're going to start forming our own equation. So what we do is we say that the equation of the parallel line is y equals 3x plus c. Now, we've got part of this there for us from the initial part here. What we want to do is use this here, the point that we're given it for a reason, to work out c. And what we do is we do x equals 5, y equals 8, and we substitute this in to this equation. Similar to how when we were proving that points were on a straight line, this should be able to allow us to rearrange this to find out c. So what we do is we say y equals 8, and then we go 3 times 5 plus c. 8 equals 3 times 5 is 15 plus c, and then we take off our 15 from both sides to work out that c equals minus 7. What we then do is we take that value for c and we put it back into there, and that is our equation for a parallel line. I'm going to go through question J from the questions that you've got on page 2 from question 5, because this does ask you to do one extra step in it, and I just wanted to model this for you so that you knew how to do it. So we follow the same steps that we've done before. The only difference is this isn't a y equals equation, so what we have to do is divide both sides by 2 first, and if we do that we get 3x plus 1.5. Now we want to work out the parallel line, so the same thing that we did in our last example. We say that the gradient for this equals 3, and we start with our y equals mx plus c, and we substitute in our 3 and we get y equals 3x plus c. We're then told a coordinate, so we do exactly the same thing. X equals minus 3 because that's the x coordinate, y equals 4 because that is the y coordinate, and then we substitute that into our equation up here. So we get 4 equals 3 times minus 3 plus c. Work out 3 times minus 3 and that gives us minus 9 plus c. You then rearrange this and do the inverse operation. So you've got minus 9, so you add 9 to both sides. That gives you 13 equals c. And then what we do is we put that up here and we get y equals 3x plus 13. So for this, I'll just quickly talk you through what I've done again. Divided by 2 because we always have to have our equation in the form y equals for us to identify the gradient. I identified that the gradient was 3 and I substituted this into y equals mx plus c and got y equals 3x plus c. I then took my point, which was minus 3, 4, substituted these coordinates into this equation here, and I got 4 equals 3 times minus 3 plus c. I then got 4 equals minus 9 plus c because I did 3 times minus 3. I did the inverse operation of minus 9 to move this to the other side. That gave me 13. And once I get c equals 13, I put it back into my equation from here to show what the final parallel equation of the parallel line would be. Can you use this to complete the questions on page 2 of your Knowledge Organiser and any questions set on Maths Watch? Thank you.